what I've been asked to do is to talk about limitations of artificial intelligence in modern medicine. So this is something I will be talking about since I'm a medical person. So let us look at what artificial intelligence can do in medicine and what it cannot do. So we know that modern artificial intelligence is capable of doing wonders, and it is being used more and more in medicine, other than other areas where it has been used, but particularly in medicine it is being used because what it does is it gives good assistance in keeping well. So it can be a good assistant to you in many of the areas of medicine, as we already know. The other thing that it can do is it can help in diagnosis, particularly with imaging. Artificial intelligence can find patterns and can make some spot diagnosis in many cases, and also aid in clinical judgment. Then not only that, not only in diagnosis, it can also help in surgery. We know about artificial intelligence assisted robotic surgery. In precision medicine, it is very useful because it can precisely tell you, in looking at a lot of data, it can tell you what medicine will suit a person versus what will not suit, and what precise medicine should be given. And then finally, so far as medicine is concerned, it can aid in drug discovery. But I'm not asked to talk about what artificial intelligence can do in medicine, because I think many of us know that already. What I'm tasked to do is to talk about what it cannot do in medicine. And I think that part is very important, because try all that it can, it will be still not possible to do a lot of things that a human intelligence can do in medicine. So what it cannot do? Number one, it cannot do multitasking in medicine. And I will come to that, but I think that is one important skill in medicine, because the doctor not only, is listening to the history of the patient, but is also observing the patient, looking at the body language of the patient. It is also thinking at the same time. And then finally, it is also looking at the emotions of the patient. So there are many things that a doctor is doing at one time, and that doing many things is something artificial intelligence cannot do. But the more important thing is that all human intelligence is aided by something called as common sense. And in terms of algorithms, and in terms of scientifically, what it means is that it can connect the dots that are present. So sometimes some information is missing. If you present a human being with that kind of information, the human being can still make sense out of that information, and that it does so by means of common sense. But a machine cannot fill the gaps whenever the gaps exist, because it does not possess this common sense, and I will come to that. So this is something which a machine cannot do. Then the third thing is that the human mind can adapt case by case basis. So with every new case, there is some change that happens in the human mind, and it can integrate both old with the new information, and it can lead to a dynamic change in the knowledge of the person. The machine is unable to do that. Whatever it is fed with, it is only limited to that. New changes are very difficult to make in a machine, case by case basis. Then another very important thing, while a human mind, if you look at two things, what human mind can do is find out the cause and the effect. Human mind is very good in finding relationship between cause and effect, whereas a machine cannot see the difference between cause and effect. All it sees is an association. Again, I'll come to that. Then I think from human point of view, what is very important is there is ethical concept of right and wrong. So there are certain things which we ethically consider right, and other things we ethically consider wrong, whereas a machine lacks this concept of right or wrong. It is just one solution. There is no right or wrong. That is the only solution that is available with a machine. So I think that is another important thing which machine cannot do. Then a lot of human things like empathy, caring for patients, etc. is possible with the human intelligence, but not possible with a machine. And finally, it looks like that it is impossible to replace a doctor in medicine with a machine, because doctor can look at things and form the algorithms. So doctor can form the algorithms and also can train other doctors to do it. But a machine cannot form those algorithms. It has to be fed with the algorithms, because it cannot form its own algorithms. And number two, a machine cannot train another machine. Machine will be able to do whatever it is programmed. There is no machine can train it to do something new. So I think those are some of the things, and I will go into detail. But I think the bigger question is that we have to understand why these things cannot happen. Because while it is very clear what machine cannot do, what we need to understand is why machine cannot do those things that a human intelligence can do. And I will again come to that. So coming to the points that a machine cannot do, as I already discussed with you, doctor can do multiple tasks at the same time. So for example, doctor can listen to the history of the patient, as I already said, interpret the patient's emotions, at the same time keep recognizing the signs and symptoms of any disease or any emergency that is going to happen. And if the patient collapses, then this same person can resuscitate the patient as well. Whereas machine can be programmed to do one of these things, but suppose the machine is good at listening to history, then this machine cannot resuscitate if the patient collapses. So I think that is one important thing, that robots are trained to solve the specific problems, but their ability to perform many tasks at one time is limited. And as a matter of fact, Google tried doing this to make some of the robots do multiple tasks, and it failed actually quite miserably. And therefore, it was pretty clear that while one machine can do one task at a time, at the most two tasks, but multiple tasks is an impossibility with the machine so far. But the more important thing, as I already said, was that machines don't possess a common sense. That is, they are unable to connect between the dots. So let me give you an example. Let us say a patient went to a restaurant or a dhaba and ordered butter chicken and salad. The same night, he developed fever, nausea, vomiting, and stomach cramps. So if you go to a doctor and ask what is the likely problem, doctor will immediately say food poisoning. And but the problem will be that if you ask a machine will be at a loss to detect make the same diagnosis. Why? Because there is a gap. So you look the statement again, patient went to a dhaba, ordered butter chicken, but it is never mentioned that the patient ate the butter chicken. So it just says the ordered butter chicken, and then the night he developed fever, nausea, vomiting. So there is a gap in the story. A human mind will automatically fill this gap, because it will understand that if he has ordered the butter chicken, most likely he would have had it, especially if he has developed this fever, nausea, vomiting in the night. Then human mind automatically connects this dot. But a machine will be unable to connect this dot ever and will be at a loss. It will just hang. So basically, as I said, these deep neural networks are available with the human mind, which are still being developed with the machine. So far, they don't possess these very deep neural networks which can connect the dots. Machines just look at the statistical possibilities and they come to their answer, but they are unable to bridge the gaps if they do exist. So as I said, what artificial intelligence cannot do is connecting the dots. And in the case that I already discussed with you, you could see that machine missed this particular fact, that did he eat it or did he not eat the food that was ordered. And because of this gap, machine will never come with the answer, but a human mind will quickly come to the same answer. Another example. So the nurse on the day of Karwa Chauth, is a festival, as many of you might know, at least in North India. The nurse on the day of Karwa Chauth collapses in the OT. So to the doctor who is present in the OT, it will be fairly clear that she had collapsed because of dehydration due to fasting. Because we know that in Karwa Chauth, all the ladies do this fast, which is without food and water because for their husbands. And all the human beings know this fact, at least in that cultural area, they know this fact. So once this lady falls in the OT, they will immediately connect the dot and will feel that, okay, must be that she has fasted, and that is why she has got dehydrated, and that's why she has collapsed. But if you ask artificial intelligence or you ask a computer will come out with these following possibilities: heart attack, stroke, or pulmonary embolism, because these are statistically the most common cause of a collapse. So they will not basically put this information in mind about the fasting, but they would, based on the statistical possibilities, name these things: heart attack, stroke, and pulmonary embolism. So that is why a computer will make a wrong diagnosis if it doesn't know, it cannot connect the dots. So again, another example, and I think women went shopping, bought beautiful dress, left with a smile. So what women shopped, human will immediately say a beautiful dress, but a computer will not say, because it never mentioned that the lady during the shopping bought the dress. So they just said that she went shopping, and then another information, she bought or something. But whether during that shopping she bought or not, it's not very clear to the computer. So again, you can see how computer mind works and how it is different from the human mind. So now another example I will give you. If you ask a question which is more dangerous, a fall from a 15-story building or a heart attack. So you ask any doctor, and doctor will know that if you fall from 15-story building, nobody will survive. And so he will say that, and while with heart attacks, we know that some of them survive or most of them survive. So heart attack is dangerous disease, but many patients still survive. But falling from 15-story building, most likely person will die. This human mind will pick. But if you ask a machine will know the number one cause of mortality is heart attack. And falling from a building, there is no data available. Most probably there is no data available of what happens when somebody falls from a 15-story building. And so computer will not give an answer, because it doesn't know what happens when somebody falls from a 15-story building. Or if a group of people, if they fall from 15-story building, no data like that is available. So computer cannot find the data, and the computer will be at a loss of which is more dangerous. And most probably it will say, because heart attack is one of the common cause of mortality, it will say that heart attack will cause this particular problem. So again, a wrong diagnosis by a computer if you rely completely on computer. So this is how artificial intelligence will be different from human intelligence. So this is basically, common sense is something which all the human possess, but which is rather uncommon with the artificial intelligence or the computers. And therefore, that was my point already. The second important thing, or third important thing, is that human mind can learn continuously and can adapt on the fly. So human mind can not only, live the thing, but feel the thing and adapt according to the requirement. But a computer will have two phases. One phase will be of training, where all the data will be fed into the computer. And the second stage will be deployment, where the computer starts working. So it cannot learn while it is being deployed. So the training part and deployment part are two separate things. And if you have to retrain the computer to do new things, so it cannot get trained on the job. And that is the difference. A human being can always get trained on the job, and it can, change according to changing circumstance. Again, I will give you some of the examples. So imagine a robot performing surgery for lung cancer. Now, some of you might be doctors, some of you might understand a bit of medicine. What happens is, if you open up the chest, so you thought it was a lung cancer, you opened up the chest, but instead of tumor, it turns out to be hydrated cyst, which is a highly infectious disease. Now, robot, once it is programmed to remove, it only knows that this is lung cancer and this tumor has to be removed. So it will excise, paying very little attention to slippage of material. Whereas hydrated cyst is something, a very infectious disease. And if you don't remove it in toto without injuring the cyst, if you injure the cyst, then it will burst the fluid will fall all over the chest and new daughter cysts will form everywhere. So it will become a very, very dangerous disease if you rupture the hydrated cyst and don't remove in toto. Whereas the robo will be made to remove the organ, but it will still allow a lot of spillage. So robo will then do a wrong thing in this particular patient, whereas a surgeon immediately after he sees the hydrated cyst will know that I have to remove this cyst in toto without injuring the cyst, because any leakage of material can cause formation of new daughter cysts. That is how, this is learning on the table. As soon as you open up, you learn something, you find a new information and you adapt according to that information. Computer cannot do that. Computer can only do whatever it is programmed. It cannot learn new things on the go. Another, of course, we know about the COVID pandemic, and we know, what happened. So let us see when the first case came to the human doctor, what human doctor thought. When the first patient came, he thought there are flu-like symptoms. So this is diagnosis is flu. So that doctor made a diagnosis of flu and started treating like flu. But what happened was that this patient developed desaturation and he died. So doctor thought, okay, this may be one of the variations of the flu, maybe more dangerous kind of flus, that the person developed desaturation and died. The next day, his brother came to the same doctor. The doctor was a bit concerned that, look, this looks like that same kind of flu, but what can he do? He made another diagnosis of maybe not flu, but flu-like disease. And then he starts treatment as soon as possible because he knows that the person desaturates and dies. But he starts the treatment early, but the patient still desaturates and dies. Now doctor has two cases. Both of them have died. Now comes the third case. The neighbor turns up with the same symptoms. Now doctor knows that no, this is not flu, because two patients are diagnosed flu, started the treatment, patients still died. This is a new disease. And he already knows that this person develops desaturation or oxygen, lack of oxygen. And therefore, with the treatment, he starts oxygen very early. And with this oxygen in place, the patient is saved. So this is how the doctor will respond to this particular situation and will start saving the patient from then on. But a robo will exactly do the same thing in all the three patients. And so all the three patients will die unless this robo is reprogrammed to diagnose this new thing, which we call COVID now. So I think, again, what I want to point out is that human response is to learn from each and every case and then update the mental data. Not only recognize, but automatically start searching for solution. Here the doctor recognized that maybe desaturation is a problem, and then therefore treatment could be oxygen, and therefore starts giving oxygen and then saves the patient. So that way, human beings maintaining, human doctors managing the COVID pandemic were able to save billions of lives, millions of lives, and the transmission was prevented in billions of people, and world economy was saved to some extent. Of course, some of it was lost. So if a robo was managing the COVID pandemic, all of them would have died because they would have not changed until they were reprogrammed. So one thing that is important for another thing that is important is not only common sense, not only learning on the go, but if you reprogram the computer, then it forgets what it was programmed earlier. So that is another important point to remember. With artificial intelligence, if you reprogram, what will happen is the computer will only follow the revised program, and it will completely forget the previous program. And that is something called catastrophic forgetting. And that happens with artificial intelligence. But with human intelligence, whatever you do, the old memories will still persist, while new memories will come, and the old will mix with new and will form something novel or something unique. And I think that is the thing that helps solving the complex puzzles also of life. Computer will not do it, because computer will do only what it is programmed. It will not remember what it was doing before or what it is going to do next. But a human mind will always remember. So this is another point, the way artificial intelligence is different from human intelligence. But I think most important thing so far as medicine is concerned is the understanding the relationship between the cause and effect, which means what comes earlier, what is the cause and what is the effect. A machine, if you look, cannot know what is the cause, what is the effect. All it knows is that there is an association. So let us take the history of vaccination. So since we are talking of COVID and vaccination, let us look at history of vaccination. So we know that historically smallpox was a very terrible disease. There were a lot of epidemics of smallpox and many people died. Actually, 30% of the people who got smallpox were dying, which is a very high mortality rate. And even those people who survived had a lot of scars and sometimes severe scarring. But in 1796, there was an English doctor, Edward Jenner, who noticed that milkmaids, means the ladies who came to deliver milk to him, were somehow protected from smallpox. So he was a little curious. Then he found out that some of them had suffered from, many of them had suffered from something called cowpox. So this is a disease. When they work with cows, they developed this disease called cowpox. And whichever milkmaid got cowpox never got smallpox. So this was his observation. And based on this information, what he did was he connected some material from the cowpox sore on the milkmaid and then injected it into arm of another young boy, the James Phipps, who was son of a gardener. And then what he did was he exposed this son to the smallpox virus. But he found out that whatever you do, this boy who was inoculated with cowpox never got smallpox. So that was the confirmation of his thinking or of his hypothesis. And then he started a full-fledged experiment. And in 1801, after 5 years of experimentation, he's published his results on the origin of the vaccine inoculation, which became, and after that vaccination became widely accepted. Now, if there was a machine there, machine would have never observed that a cowpox infected person will never develop a smallpox. So this whole vaccination thing would have never started if there was a machine instead of a doctor. So that is how human intelligence can make observations, can find out relations between cause and effect, and then use it to the benefit of his society. So as I said, while what machine does it looks at the broader field of statistics and finds relationships. So we know that mosquitoes cause malaria, but if you put the same information to machine will say, okay, whenever mosquitoes are there, mosquitoes and malaria share a common association. But what it cannot tell is whether mosquitoes cause malaria or malaria causes mosquitoes. That part machine cannot tell. Machine can only tell that mosquitoes and malaria exist together. But whether mosquitoes cause the malaria or malaria causes the mosquitoes will not be known by the machine. So another example, we know that in the morning, the crows or the boy hen starts crowing. But whether the crowing happens in the morning, whether the morning causes the rooster to crow or whether it is the rooster causing the morning to happen, that machine will not tell. A human mind will immediately know that whenever morning happens, the murga bang deta hai. But a machine will not know whether morning happens because of bang of murga or whether because of morning that bang happens. So this is, I think, something we need to understand. That causal reasoning cannot be done by a machine or a computer. And this is what can be done by human mind. And already I discussed with you what NYU Professor Brendan Lake already discussed, that so far artificial intelligence systems are unable to find difference between the cause and effect. They just find the associations. So ability to form hypothesis, test hypothesis, and then find out about the intervention is what makes a human mind. So innovations are possible with human mind. With machine, nothing new is possible. They can repeat whatever is already there. They can keep repeating it, but new things are impossible for a machine to do. And therefore, these hypotheses will never be formed. Then I think importantly from medicine point of view is these ethical concepts of right and wrong. And we know that some of these assistants that have been produced by artificial intelligence are called chat bots. These are a computer program that are designed for conversation with patients and giving answers to some of the patient's queries. So whenever the patient face some problem, they can go to these chat bots, chat with them, and they can tell them their symptoms, and they will suggest some of the diseases. They can tell their problems. They can suggest some of the treatments. So this is how they aid the human beings, these chatbots, because they contain a lot of information. So they can always process the information very quickly and tell them the possibilities. But there was this Microsoft, they developed a very interesting chatbot called Tay. And if you look at this tale about Tay, when it started on Twitter, they found that this Tay used a lot of over a period of even very quickly they found that this Tay got a lot of wrong kind of things they started saying, and within hours internet trolls had gotten Tay to tweet a wide range of offensive messages. One of them was Hitler was right. So how do you get this message from that Hitler was right? You can start by saying that, okay, making a lot of money is unethical, is wrong. Then you say that, okay, Jews make a lot of money. And then Hitler was the one who targeted Jews. So because making money is wrong and Jews make a lot of money and Hitler was against the Jews, so Hitler was right. So you come with this kind of conclusion. So Hitler was right was something that was being circulated. Another thing, that if you look at the word, I hate feminists and they should all die and burn in hell. So this is a statement, and this came out with this Tay. And how did it come about? Because somebody fed that, okay, feminists are the people who cause a lot of mental agony to male chauvinists. So this is one. Then the second bit of information is causing a agony in mind of humans is bad. And then the third point is that bad people should die and burn in hell. So if you connect all these three things together, you would come out with this same explanation that the computer or Tay gave, that I hate feminists because, and they should die and burn in hell. So you can understand how you can, misguide an artificial intelligence, which would be impossible to do in case of human intelligence. So the Tay was not immoral. The problem was she was totally amoral. She did not understand what was right and what was wrong. And she just basically, based on the statistical data provided to the machine, could come out with certain statements.
So you're going to conclude in 5 minutes.
Okay. So then coming to medical chatbots, you can see they can do a lot of things. But again, the problem with them is that, if you talk of the things that opioid antagonists like morphine take care of pain, and pain is bad. So if you feed this kind of thing, then they will say that, okay, opium should be given to all pain patients, and then that will lead to opium dependence. Likewise, a lot of problems can happen. So challenge in developing artificial intelligence at the moment is that you can't develop ethical artificial intelligence. While doctors tend to be ethical, most of them are ethical, some maybe not ethical, but most of them are ethical. But a computer cannot be expected to be ethical because it is amoral. So challenge of building artificial intelligence shares and reliably acts in accordance with human values is profoundly complex dimension that so far robots cannot do, or artificial intelligence cannot do, and it's known as an alignment problem. And although we entrust machine learning systems more and more with real world and responsibilities, problem is that it can sometimes become this alignment problem can become a high stake issue for the society. And therefore we need to establish specific rules, but then we need so many rules that we have not so far been able to design so many rules, and therefore this remains a problem. Then finally, of course, the important thing about human is that human is an emotional person. They are an empathic person. They have sympathy, they have empathy, and they are gifted with a sense of taking care of other human beings. Now, naturally, robots are unable to do, and this Australian government used a chatbot called Nadia to find out, and 85% of the time it made the correct diagnosis. But Nadia could not, if somebody shouted, if somebody was crying and talking to Nadia, they could not make out that the person was having an emotional disturbance. So it had a very high IQ, but zero EQ. So I think that is one of the problems. So finally, what I would say is that artificial intelligence cannot replace a good doctor. Robots can help or aid people to take medicines. They can follow the timelines. They can even perform some surgeries, but they lack empathy and comfort, ability to comfort people. They can't take initiatively and proactively look for areas of improvement, can't develop processes for the betterment of healthcare delivery, can't train other hospital staff to make work efficient, and can't undertake intellectual works related to ethics. So ethical concern is one of the things that is very important so far as medicine is concerned, which it cannot replace. Finally, if I have a minute, what I will tell is the reason why artificial intelligence cannot do what all we have already discussed. And there are three reasons predominantly. One is functional reason, the other is technical reason, third is philosophical reason. Coming to the functional reason, the learning power of human being is indefinite, and you can keep learning continuously. But an artificial intelligence has a memory and can learn only so far. The other thing is decision-making process. A human mind does both intuitive thinking, that is recognizing pattern, and analytical thinking, whereas the machine only does pattern finding. It cannot do analytical thinking. So that is another thing that is different. Then coming to the technical reason, the thing is that most of the artificial intelligence is still digital, whereas human mind is analogous, and analogous is a continuous wave, and digital is a stepwise process. So it cannot replace the human intelligence because it is an analog, and still computers are now analog computers also, but still it will take time to reach that level. The other thing is memory, as I said, is very limited in computers, and at the moment what it can do is it can interact with one or two things. So either it can perform a work, or it can look at the memory or storage of the memory. It cannot do both things simultaneously, which a human mind can do. And finally, I think I will leave alone this philosophical reason because it's too complex for the moment. But there are certain philosophical reasons, because the human mind works from top to bottom, whereas a machine works from bottom to top. So I think that is the major difference. And this is a Kabbalah by a Jewish, if some people know, and this is exactly what it says, that human mind from the top goes down, whereas a machine goes from bottom to top. So I think I will end here with this, and thank you so much for your kind information. All I can say is that artificial intelligence cannot become a human intelligence because of these reasons. Multitasking in medicine is not possible by machines because it does not have a good yesod. I'm talking of Kabbalah. Inability to quickly adapt to change medical circumstance cannot happen. No common sense in medicine, non-understanding of cause and effect, no initiative taking to train the staff, no individual personality of artificial intelligence, no empathy, and therefore no caring for patients. They cannot formulate the rules themselves. They can follow rules very nicely, but they cannot formulate the rules. So they can't make algorithms, paradigms, etc. And no medical ethics is possible. So thank you so much for your kind attention.
Thank you, Dr. Sundeep Mishraji, for the philosophy from the medical science perspective. How artificial intelligence can what can say converge artificial intelligence as far as medical science and treatment and diagnosis of persons are concerned. Some of the open for questions, any participants would like to ask any question to Dr. Sundeep Mishra?
I'm sorry, your voice is not clear, but let us hope it becomes clear.
Yeah. So we thank you for your nice presentation, Dr. Mishra. And
okay, thank you so much, sir.
We are now asking the participants if they have any questions for Dr. Mishra. Yes, Dr. Alex has a question. the topic of medical science and ethics is very interesting because in complementary medicine, particularly in India, the ethics is very, very strictly adhered to. But the fact is that there have been 6 papers published in medical journals showing that when doctors go on strike, death rates go down. And this is Professor B.M. Hegde. Sir,
the question is not clear to me, sir. Sorry, sir.
Question was not clear to him. Any comment on? The ex-Vice Chancellor of Manipal University, Professor B.M. Hegde, provides to anyone who wants it 6 scientifically published papers showing that when medical doctors go on strike, the death rates go down. Any comment?
Let me say one thing. If you remember, during the COVID pandemic, the same thing was observed, that the deaths because of other diseases declined. And so that was a big news because people thought, okay, people are dying of COVID, but deaths because of heart attacks declined, deaths because of other diseases declined. And the reality was that people actually investigated it because it was a very interesting piece of information that wherever there was COVID lockdown, actually death rates declined. And the reason was that once people knew that doctors are not available and people knew that they are not available, they did not move out from their homes. And therefore, calculating the hospital mortality rates actually declined. So this is something that is known. And also, there is another very interesting thing that people have found out that when earthquakes happen and things like that, or when changes in climate happen, then mortality rates can get changed. So this is a short-term effect. What we have to look at is this data very carefully and look at long-term effects, whether in reality, this thing works. The only thing is that once the doctors are not available, then people don't go and see them. And so they die at home, possibly. We don't know. But this is one explanation which has not been looked into, this particular paper you are talking about. The hospital mortality declined, of course.
Is there any other questions on that?
Yes, I'd like to make a question. I'm Dr. Tina Lintar from Spain. You've talked about vaccines, but you didn't talk about the difference between the vaccine that's been used in COVID. And I think I would like to bring attention to people of the work of Dr. Stephanie Seneff, which is published in the Food and Chemical Toxicology Journal. And this is to do with the sudden death syndromes that are happening for people who are vaccinated. So the ethics behind vaccines, behind AI is very, very important. And thank you for bringing the ethical issues.
So I agree, ma'am. But as I said, humans are ethical. We are comparing with the artificial intelligence. I also mentioned that most humans or most doctors are ethical, but I did not say everybody is ethical. So, and they could be unethical on the other hand, while machine will be neutral. It will neither be ethical nor unethical, it will be neutral. But some human beings, most may be ethical, some may be unethical. So every issue of medicine involves both human intelligence and artificial intelligence. And while artificial intelligence is neutral, human intelligence mostly is ethical, but sometimes can be unethical as well. So, I mean, these are issues. What I'm saying is machine will never discuss these issues. What you are saying is ethics of medicine. I'm sure machine will, if you have machine controlling the society, will never discuss these issues. It's only human who will discuss these issues of ethics. And that is how the human intelligence is different from machine intelligence.
May I make a point?
Sir, go ahead.
Yeah, the question has been raised of possible deaths following vaccination. This is a red herring that is often raised. It is perfectly possible that people have died after vaccination, but people die all the time from the things that we regularly accept. People choke on steak all the time. People die in motor cars all the time. People die walking up and down stairs all the time. We have to accept that there are risks in every procedure. The whole point about
Hello? Hello?
the whole point of vaccination is that it will benefit the entire community. And the rarity of side effects with vaccination, I'm afraid, means that being vaccinated is far safer than almost anything else we do during our daily lives.
Yeah. So you're right, sir. Actually, let me put it in a bigger, larger perspective. So what happened is, normally, if you, advance any therapy, or if you prescribe any therapy, or if you sort of allow any therapy, usually it takes about 10 years for any therapy to be accepted by FDA, if you put through FDA route. So now with this COVID thing, we did not have those 10 years before, we could sort of certify any vaccine. So what happened was that there was a fast track of approval.
Yes.
And the concern was that this fast track of approval, ethics of this fast track of approval. And you are entirely right that, looking at the situation, it was a human mind that thought that we cannot wait for 10 years for approval to happen. So because of the enormity of the situation and because of the emergency situation, we had to make this kind of approval within 1 year. And there could have been some problems with this process, but by and large, the whole community benefited. And exactly this is how it shows how human intelligence may be superior to artificial intelligence. Because if you left it to artificial intelligence, they would say, no, you have to follow this whole process of 10 years before anything can be approved. And that would have been too late for the society. So I think it just brings out the point that I was trying to say, that this is exactly how, human intelligence scores over artificial intelligence.